Good morning, everyone. This is Sachin Fiske from Electrical Engineering Department, SND College of Engineering and Research Center. Today we are starting a SCADA system, and that first point is introduction to the SCADA system. Let us start. So, what is SCADA or what the SCADA stands for? So, it is a supervisory control and data acquisition system. Basically, the real-time industrial process control system used to centrally monitor and control the remote or local industrial equipment such as motors, valves, pumps, relays, sensors, etc. The SCADA is the combination of telemetry and data acquisition system. Precision without the SCADA software and industrial process was entirely controlled by PLC, CNC, PID, and microcontrollers having programmed in certain language or codes. These codes were either written in assembly language or relay logic without any true animations that would explain the process running. It is always easy to understand the status of the process if it is shown with some animations rather than written codes. And hence, the SCADA software came to existence with some exclusive features. It became internal part of automation system. SCADA is not just hardware but also a software. It is a concept. Its system as a combination of special hardware, software, and protocols. SCADA is used to control the chemical plant process, oil and gas pipelines, electrical generation and transmission equipment, manufacturing facilities, water purification and distribution infrastructure, etc. Let us take one example. In a SCADA system, a PLC can be used to control the flow of cooling water as a part of an industrial process. At the same time, the supervisor can use the host control function to set the temperature for the flow of water. It can also have alarm and can record the flow of water temperature and report back to the RTUs. And PLC are responsible for data collection such as meter reading, equipment status, etc. and communicate back to the SCADA system. This data can be stored in a database for later analysis or monitored by a supervisor to take appropriate action if required. SCADA system typically implements a distributed database commonly referred to as a tag database, which contains the data element called tags or points. A point represents a single input or output value monitored or controlled by the system. Points can either hard or soft. A hard point is a representative of an actual input or output connected to the system, while a soft point represents the result of logic and math operation applied to other hard and soft points. Most implementation conceptually remove this distinction by making every property a soft point that can equal a signal hard point in the simplest case. Point values are normally stored as the value timestamp combination. The values and the timestamp when the value was recorded or calculated. A series of a value stamp combination is the history of that particular point, and it also common to store the additional metadata with the tags such as path to field device and the PLC register, design time comments, and even alarming the information. This is all about the basic or very basic information of the SCADA system. Means what the SCADA can do or how this process will be implemented is given here. Thank you.